Hey folks, welcome back to the shop. Frank here. Continuing to work on the articulating Cub Cadet dump truck slash tractor. Last time we started working on the joint between the front frame and the rear frame, between the front drive line and the rear drive line, the articulation point. So kind of mapped out an idea of how it's going to work. We started working on the drive line components, the shafts and stuff. So just got started last week. We've got quite a bit more to do. This week I'm going to work on the CV joint. So we're going to take that apart, probably machine both parts of it, both shafts that come out of it, so we can insert it into the drive line. So that's where we're going to start today, and we'll see how far we can get. So let's get started. All right, so this is a drive shaft from, I guess it's from an ATV type vehicle. It's not from an automobile. I think it's a quad. Anyway, the automobile CV joints are a little bit large. I do have one of those, but I've decided I'm going to use this because it's smaller scale. We're only talking 15 horsepower. So I felt like this would adapt better to our drive line than a larger one. So I'm going to take it apart here, take these boots off. Got the boot off here. Wipe away some more of the grease. All right, some of the CV joints come with a ring, retaining ring you can remove. This one is, I think, if I'm not mistaken, has a circlip on the shaft here. So this is just a matter of driving this off, and I'm pounding on the star. There we go. Yeah, so it has a spring ring here, which is, you need to overcome the compression of that ring to get it to come out of the star. All right, so I'm going to clean this up. All right, so we get this boot off. You know, I thought about maybe putting it in the lathe and turning it off. Maybe we'll do that. See if I can fit this in the, see if I can run this in the lathe with this in on a live center. Got the axle in the lathe here and the universal joint pressed up against a live center. So I think I can turn it this way. I'm going to try to remove the weld here so I can knock this universal joint off this shaft while, you know, preserving the spline connection. All right, got this clamped in the vise. Oh, it comes right off. Look at that. Okay, that'll be our coupler between this CV joint and the drive shaft. All right, that's perfect. All right, so this shaft is going to 3/4 of an inch. All right, after dealing with this hard material for quite a long time, I finally got it down to 3/4 of an inch, which is, I've got a good fit here. I actually used a file to get the last couple thousandths off because I was getting a little bit of a taper. So I was a couple thousandths over here, and I was concerned if I kept working on it, I'd wind up being too loose down here. So just used a file and evened it out. And so finally got down to 3/4 for these bearings. All right, this is the second bearing plate heading front to back. This is, this is 1/4 inch. If you haven't seen, me cutting stuff out on the plasma table before, the plasma table does a really nice job. You do get a little bit of dross or slag around the back edges that just knocks right off. You have to push it toward the edge to knock it off. There's very little dross on 1/4 inch and thinner stuff. 3/8 I have a little more dross. All right, so I've got one plate in there, one bearing plate, takes the drive shaft from the transmission. This one will support the forward end of the CV joint. These bolts are temporary at this point. These are actually a little bit too long. Though the length is not really a problem, per se. All right. This is going to go in like this. Once I loosen the set screws. All right, and of course I've had this rubber glove over the CV joint to keep debris out of it while I'm working with it. And we'll put it back together. All right, so that's there, all right. All right, let's test fit up our front half of our drive line here. All right, that gives me a little bit of adjustment still for aligning the pivot point of the CV to the holes here in the frame. I'll come back and we'll drill the holes for the pins. It'll be a roll pin here, roll pin here, roll pin here. That'll allow disassembly. All right, this is the boss I turned on the lathe, and I need to turn, 3 more of them. Unfortunately, I discovered that this stock is actually stainless, and it started to work harden on one of my drill bits and ruined the drill bit. And then I put it, without realizing, I put another drill bit in, and of course it ruined it. So that's a problem with stainless. I didn't realize. It was stock that I inherited from a yard sale. I didn't know what it was. But machined fine with carbide until I started drilling the holes and it was squealing. Anyway, I've ordered some more 2-inch round stock, and so these bosses will fit in here, and the 1-inch pivoting shaft pins will fit in there, so it'll separate them. Actually, this one will go on this side underneath, and the other one, the other plate, the other pivot plate will go on the outside. It'll go on the outside of that plate. I'm getting set up to bore the center of this hub for a bearing. We'll do the other side as well. The drive shaft we have is 3/4 of an inch. It's going to go through here. We want it to be supported by a bearing. This hub will allow the back of the tractor to rotate independent of the front of the tractor. So one side will be attached to the front of the tractor, the other flange will be attached to the rear of the tractor. So the drive shaft will go through the middle of this. So I've got my coaxial indicator here set up. And let's go down here and get on. There's a machined bevel on this particular bore. All right, that's plenty close. All right, I've got a carbide tipped annular cutter in a Weldon shank adapter. This is an 1.5 inch cutter. I need a 1 5/8 inch or just under 1 5/8 inch bore. So we'll do most of the bore with this. At the depth of cut is going to be 0.44 or 0.45 inches. This is the bearing that I'm going to use. It's a high speed 1 5/8 inch outer diameter, 3/4 inch bore, and it'll sit in about just less than 1/2 inch, 0.44. I think I'm going to come in, it's left an inner ring. If you can see, there's an inner ring here. So I'm going to come in with a slightly smaller one and remove that ring. All right, so that's a little undersized for the bearing. So we're going to get a boring bar and bore it out for a snug fit. I'm at an impasse at this point due to a mistake I made in boring the hub. So I needed a 1 5/8 inch bore to press in the bearings for the drive shaft. And I started out with an 1.5 inch annular cutter thinking I could use a boring head to go the rest of the way. It's just not working. The material is too hard. So the annular cutter has carbide teeth and it worked fine. I got my 1.5 inch bore, no problem. 1 5/8 I can't get there with the tooling I have. So I've ordered a second, another annular cutter, 1 5/8", carbide teeth on it. It won't have any problem finishing off the boring operation. But I'm kind of stuck at this point until I can do that, because I need that hub, which allows the rear frame to rotate independently of the front frame, or roll rather. I can't get any further on this until I get that cutter and finish boring the hub. And then I get the bearings pressed in. We can then set that up in the articulation in the joint and make decision on the dimensions for the rear half of that joint, which is where I'm headed next. So next week we'll come back and we'll finish boring the hub and press the bearings in, get that mounted so we can assess the size of the rear half of the articulation and start building the frame out, reinforcement frame for the rear half of the tractor. So that's where we're going. Thanks for watching. We'll see you then.